So we'll move on to number 5A now. This is going to be a little bit more tricky for me, not having a protractor here, but I'll do my best. So I have pi over 6 is less than or equal to arg z, whoops, arg z is less than or equal to pi over 2. Okay, well, if it's just arg z, you want to just start from the center here, from the origin. Pi over 6. Now, pi over 6 is, I think, what is it, 30 degrees. So we're heading out sort of, I guess, like, roughly this way, okay? Roughly, you get the general idea, right? So this would be pi over 6 here. Okay, and we know that arg z is greater than that, but it's less than or equal to pi over 2, which is up this way. Okay, so in other words, we're dealing, our z must be in this area here. Okay, let's try the next one from 5, which I'm going to do as 5D. So with 5D, what have we got? 5D, we have arg minus pi over 3. Oh, interesting, yeah, that's good. Minus pi over 3 is less than or equal to arg, and now this time we've got our brackets, z minus 5 plus 3i, the bracket, is less than or equal to pi over 2. Okay. So negative pi over 3 is like a 60 degree angle. First of all, the first step is to plot this. So I'm going to plot 5 plus 3i. 5 plus 3i is here. Okay. Now, I've got a negative pi over 3 angle, which is negative 60 degrees. So, what does that look like? Kind of like this, I think. Right, that's roughly a negative 60 degree angle. Roughly. You've got a protractor so you can get it right. Okay, so remember we're measuring our angles from this horizontal. So let's say that's pi over 3. And it's negative pi over 3. And then it's less than or equal to pi over 2. So this is pi over 2 up here. So the stuff that we're looking for, if we were to shade it, would be everything in this shaded area here. So that is 5D. Okay, I think we're going to look at number 7 now. Yes, let's look at number 7. So what do we have for number 7? I'll just rub this off. Okay, number 7. Number 7 has sketch the diagram described by, now we've got two things here. We've got z minus 2, modulus of z minus 2 is less than or equal to 2. So I'm going to do that first. Another way of writing this, and I should put it in the correct form. So I've got my modulus there. This would be 2 plus 0i less than or equal to 2. So I'm going to start and plot my point here. Okay, and from that point I've got a circle which is 2 radius. So I can, again, if you've got a compass, this is going to be a lot easier for you. I'm just putting in the points that I can easily know. Oh, that's horrible. Sometimes just going quicker is the best way. Oh dear. You get it. Oh my giddy aunt. Let's try that again. No, that's not it. Okay, that's going to have to do. Okay, so we know that it's inside that. Now the second part of this is it's also, we've got this information here, minus pi over 6 is less than or equal to arg z less than or equal to pi over 6. Now, in this case, we're starting from the origin, and we've got a 60-degree angle either, no, 30-degree angle, sorry, either root. So we've got something that goes out like this, and we've got something that goes out like this. Okay, so this angle here is pi over 3, and this angle here, sorry, pi over 6, and this angle here is pi over 6. Okay, now what are we shading? Well, both of those things have to be true. So if we are shading the region that satisfies both of those, we're shading in here and in here. So that little area there would be what we shade for number 7. Okay, the final one that I'm going to look at with you is number 10. So what do we have for number 10? Number 10. Okie dokie. This might be a little tricky. 10. Okay. We have modulus z minus square root 5 minus 2I is less than or equal to 2. Okay, I'm going to rewrite this in the correct form. So my number will look like that. Now, if I'm going to go square root 5, so that's just over 2, isn't it, really? Square root 5 is 2.23, so my centre is going to be roughly there. Okay? Roughly. And my radius is 2. So I go down to here, and I go up to there, and I go back to there, and I go back to there. Okay, so here's my circle, or my oval, as the case may be. Okay, there's my circle, roughly. And I would shade, do I have to shade anything? I think I have to shade that whole area. What does it say? Yeah, so I would shade all inside that circle. I'm not going to do that because I might need to show some other stuff on my diagram and it'll get confusing. But I would shade all of the circle inside of it. Okay. Now I've got to calculate the greatest value of z. Now remember, all of these points around my circle, right, represent possible solutions to this. So where am I going to get the greatest modulus for z? Well, I need, remember modulus is made up of the square root of the square of the coefficient of the imaginary part and the square plus the square of the real part. So you want as high for both as you can, so it's going to be out here, right? Whatever that point is. Now, what is that point? Well, we know, what do we know? How are we going to figure that one out? Well, we know from here to here, we know that length. We'll call that origin to the centre. So, yeah, I think we generally call that OC. We know what that is. And the reason we know that is because we know that it's a right-angled triangle, isn't it, right? So that is going to be equal to the square root of square root 5 squared plus, and then the y component, 2 squared. Now what does this give us? This gives us, what's that, 5 plus, so square root 9, which is 3. Okay, and then the next part we know is this bit here, this purple bit, and we know that because the radius of the circle is 2, so we'll call that C, and I'll call this D. CD equals 2, and therefore the greatest value for the modulus of Z must be equal to those two combined, right? Because if you want to look at it as a triangle, a right angle triangle, the modulus will be this bit here. Okay? Now the last thing that we need to do, I might just rub some of that junk out so that you can see. Okay. Ooh, not that bit. Okay, right. The last bit that we have to do with this question is C. Calculate the greatest value of arg Z. Now, arg Z, the greatest value, in other words, remember when we're measuring our angles, we're going this way. So how can we get the greatest argument? Well, it would be if we joined a line to this point here, if Z was there, that would give us our greatest arg. Okay, if Z was at this point here, you can see that's going to be greatest. Okay, so what are we going to do? Well, we can split it up into a couple of triangles, I guess. So we can find, actually, if you think about it, you've got this triangle here, and this triangle here are going to be equal, have equal angles. So this brown angle here and this brown angle here are going to be equal. Why? Well, because you've got a tangent here and a tangent here, and they come from the same point. So those lengths must be the same, so those two angles must be the same. So we could call one of those angles beta. So this angle here is going to be beta. How can we find out what that is? Well, it's a right angle. So this is what it looks like. That's our right angle. We want to know beta, which is there. What do we know? Well, we know that this height is 2, and we know that this here is square root 5. So we can go opposite over adjacent. So beta equals the inverse tan of 2 square root 5. Now, what the heck is that? Make sure you're in radians. 2 over square root 5, and that's giving me 0.72. Now, since we want double that, because there's 2 of those angles, we times it by 2. So I think it was 0.72 something. Therefore, greatest arg Z, whoops, not modulus Z, sorry, greatest arg Z is 1.46. And that is that one. Well, it would be good for you to try a few of these on your own. Hit me up with any questions that you have, and if you are really stuck, I can draw some diagrams and help you out that way. Alright team, wish you best of luck on it.